Hello and welcome to this latest DPA video interview. Today I'm with Darren Pratt, Product Manager for Motion Control Sensors at SICK, a company focused on sensor intelligence for factory automation, logistics automation and process automation industries. We'll be looking at ways to overcome the challenges of measuring speed and length in continuously fed and cut to length materials, including by using some promising new sensing technologies. So Darren, the need to measure speed and length is something that many engineers and machine designers have in common. In your experience, do they all face similar challenges?
Well, hello, Paige. Yeah, it's nice to be with you here today. In 25 years of motion control sensor experience, I've come across varied materials and processes, from packaging, films, plasterboard, extruded plastic pipes, for example. Now, these materials are produced in a continuous process using extrusion, casting, and blow molding. And what we see time and time again is a need for high accuracy measurement of speed and length. But this is often challenging, but so important to the process efficiency and also to the cut to length process further down the line. What we see in the cut to length process, for example, is often to fulfill the customer's order, the systems will be set up to deliver a longer length than actually ordered, to ensure that under fulfillment is not a problem. Now, with the best fit instrumentation, it's possible to tighten up the tolerances and therefore have a positive effect on the bottom line.
Thanks, Darren. Could you give us some examples, please?
Yeah, so speed and length synchronization of a manufactured product is really important to have that synchronized with the supply of the raw material to ensure good quality finished product. And then additional processing steps such as lamination, printing, labeling, and all important quality checks also place quite stringent demands on speed and length measurement.
You're talking about a lot of different products there, but I guess the type of material might make a big difference to that all-important accuracy that you get from a motion control sensor, and therefore the best technology to use.
Yes, you're right, Paige. There are some different technologies to choose from, but also some exciting new technology developments. I guess the most common technology to use is the rotary encoder, an example of which you see here. Now, the rotary encoder requires mechanical adaptation to suit the material and the process, and quite often they're applied to conveyors to form indirect measurement. But here, slippage is the real enemy, slippage between the conveyor and the material that we're measuring. Now, a common solution to that is to use a measuring wheel system. So here's an example of a measuring wheel system which consists of the encoder, a measuring wheel, and the spring. And these systems could either be homemade or a tailor-made one like the one I've got here. Now, coming into direct contact with the material brings with it some challenges. So on some materials may be abrasive and lead to wear and therefore maintenance requirements on the measuring wheel surface. And then there are other materials which may be particularly delicate and could be damaged by the measuring wheel. If we look further down the process to the piece goods, so after the cut to length process, really it's not possible to use a measuring wheel encoder to perform direct measurements. So we're back to potential slippage problems when using conveyors again.
So is there any way of getting around these problems with the material without sacrificing accuracy of the measurement?
Fortunately, there is. SICK have been working for the last 3 or 4 years on a new technology development for non-contact speed and length measurement of materials. And the first product we've produced out of this technology development is a product we call SpeedTech, which is this product here.
Oh, brilliant. So how does the SpeedTech measurement principle work to achieve a non-contact measurement?
So SpeedTech, it's a laser sensor. So it uses laser class 1 light, which is completely eye safe. And the principle we employ is the Doppler effect principle. Now, the Doppler effect is probably most associated with acoustic waves. You know, we hear it day in, day out with emergency vehicles as they travel past us. We hear the frequency shift caused by the Doppler effect, which is caused by the relative movement of the wave source to the observer. Now, we use the same principle, but in this case it's with laser light. And that means that we don't need any marks on the material or any scales to perform the measurements. We simply mount the sensor either above, below, or from the side of the material, and we can convert the frequency shift caused by the Doppler effect into incremental encoder signals. This gives us a solution which can work on virtually any material, whether it be continuous or piece parts, and we don't cause any damage to the material, and we don't have any wear potential either.
How have your customers reacted to this new technology?
So, unsurprisingly, we've had some really positive reactions to the technology. We did a lot of beta trials before bringing the product to market, and we've tested extensively on materials ranging from building materials through to packaging materials. What we've seen is that the sensor works extremely well on a wide range of materials, from shiny metal through to nearly transparent material. What customers particularly like is a plug and measure solution. No configuration necessary. It's simply mount the sensor and off you go.
So, does this mean that rotary encoders and measuring wheels are dead?
Well, that's a perfectly reasonable question, Paige, but the answer is no. We see speed tech as a complementary technology. There are still a lot of applications out there which can use a rotary encoder or a measuring wheel solution. The application requirements define the best fit technology. So what we would do is we'd encourage customers to come and have a chat with us, talk through the process with us, we'll talk through the solutions, and together we'll come together with a common solution which is a best fit for the application.
That's brilliant. Thank you very much, Darren. And to find out more about the solutions offered by SICK, please visit their website. You can also find an extended exclusive article on this topic written by Darren on the DPA website. All the details will be shared on screen shortly. Thank you very much.